Where is 129 to 54?
The page number 6.
$65. How it is came? 129, 554. How it is came?
Yij square value, sir. Don't know, sir. You only tell. Sir, మీరే చెప్పండి సార్ ఒకసారి.
Just a minute. Second one, 193, 204, 180, 211, 788. This is the value. Then where is sir? PA, DAG square. Then A value 565. 565 into 565, how much?
319,225.
You have to check all these things up to D. I'll cross again.
$559 into $565, sir, again. 594 into 565. 3356.
Correct? Or any wrong?
546 into 565. 308,490. 23. 35,1995, sir. 351,995.
Correct?
Even for TI we have to do, sir, only ABCD.
Only ABCD, that's the value. So what the TI means the sum of TJ. What? TIJ. Yij. I into J. What is I value here?
I square, no, sir, that one. The I value is 718 TI value.
No, 515554 into 515542 into 31. So I will cross 9225. 515524 into 319225. Excellent. 20. See here, I will tell you. I will clarification give you. Why ij square how it is come? Then I will tell you. Just wait. So there is a k is equal to how many here? 3. Mile serve very serve. So value is ABCD 4. N is equal to how much? 4 into 3.
Sir.
N into 4 into 3 how much?
12, sir. 12.
12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 into 3, 12. G is equal total value Pj 2328. So sigma TA square, what is the value? 1812152, and this is the value 1358306. So Yij square, summation of y is equal to 1 to k, summation of j is equal to 1 to k, 454482. So G square is equal to 2328 here, total value, TA square value, 4 square 451362. So summation of Yij square 45. How it is come? 454482. Please tell me. Once check it. What is the I value? What is the j value?
J value is 18. I mean, the summation of J is equals to 1 to H Ti square దగ్గర J ఉంది కదా సార్. రెండింటి దగ్గర J ఉంది. ఒక దగ్గర I ఉంది, ఒక
this is I, this is J. This is the row is I, this is a column J. What should we can multiply, then Yij will become?
multiply, sir.
How? Yij square. What is Yi? This is Ti. What is Yi? Where I is equal, J is equal to 1, we are substituting. How it is came 129554.
I'm also not getting it, sir.
I will cross verify and tell you. Don't worry, this one I will cross verify and tell you. And the problem, this is the values I have spoken here. So that is the value is 454482. That means minus Yij square 45. Four by 1362, the 2328 value 45162. I'm taking the value, Ti square value I'm doing it. So SSV is equal to TSS minus SST minus SSV. Sum of squares and treatments and varieties. 2851 value here. Where is it? 2850. Where is it? 2850? Tell me. Where is it? 2850. Where is 2850? You're taking the values 2850.
2850, yeah.
Sum of squares.
TSS, sir.
Then SST 1406 is correct. Yes. Then SSV 11.36. That's the value 307.33 output. So the treatment symptom, then we can write K minus 1 and 3. K minus 1, K is 3 ABC. That is 3 minus 1 is equal to SST 1406. We can write here. That mean square ST square equal to SST by K minus C. That is 1406 by 2. Then sum of square 703 by. So what is 50 error? What is the error? Error 51.22. Where we have taken? Where is from taken error 51.22?
SSC value substitute చేసేసిర్రు, sir.
Yes, correct. SSC value.
SSC and K minus 1, H minus 1.
Yes, that's
divided by
51.22. That is in the column of 2, 6. Why? Because 3 minus 1 that 1. Then H is varied with grad 4 minus 1, 3. The value 11.3637. The value is ST square by S square 378 by 1.22. Error K minus 1, H minus 1, 3 minus 1, 6 minus 1. So 2 into 5.
SSP by H minus.
Yes, K minus 1, H minus 1. So K minus 1 and H minus 1. What is the value? K minus 1.
SSC value is 307.33, sir. Divided by K minus 1 means K value is K minus 1, 2 into 3. 6.
Correct?
Oh, I'll do it, sir. 1 minute. Correct only, sir. 51.5.
Yes, then kh minus 1 is equal to 4 into 12 minus 1. So therefore, kh is equal to 50. The critical points, the critical value of 5% significant level 260 means you can use the tables and you can find out the value. So then we calculated. Then we calculate since the calculated value of point ft is greater than since critical value of the significance level 260 degrees of freedom. We reject HOE and conclude that there is a significant difference in the mean effectiveness of painkillers among the various symptoms. Since the calculated value of F is greater than critical value of 85% significance level with 360 degrees of freedom, we reject HO. We and conclude that there is significant difference in the main effectiveness of painkillers among different brands of drugs we are taking here. So then we can go on the following data. So the number of medicine products manufactured by the month, 5 workmen for 4 different machines. Therefore, you will see 5, this is 4, that is 5. The column is 4 and row is 5. So therefore, the 79, 69, 85, 66, that is a D. 83, 79, 78, 62, 63, 79, 61, 69, 83, 61, 69, 76, 89, 71. This is the value is given here. This is in the column, and this is in the row. So that is the row column is correct. Column is correct. Therefore, test whether the mean productivity is the same for the 4 machines, and the mean productivity differs from the workman performer nova. ఇప్పుడు అర్థమైందా మౌనిక YIG స్క్వేర్ ఎట్లా వచ్చింది? YIG స్క్వేర్ Monica, I am audible?
Sorry, sir. I muted it.
How it is came 22 for 22 583? How it became?
I'm also not getting it, sir. I even multiplied TI. I mean TI square into TJ square also. It's not coming. I think. Oh, we should add.
You can add it. What is coming?
1 minute. Sir, I'm adding. No, sir. 21.4. I'm getting 21.4. If I add TI square and TJ square, I'm getting 21.4717. But here it's 2258. Here it's showing 22583, sir, but I got 1214717, sir. If we add the TJ square and TI square, we are getting.
I'll cross it and I'll tell you, okay? Once again, I'll cross it and I'll tell you.
Okay. Sir.
So this is the one I will tell you, that is a K A B C D 4, which is equal to 4, maybe 1, 2, 3, 4, 5, 5 into 420. So that is the total value again 14740. For TA square 43578, TJ square 545354, 5J square total 1,09,770. So G square means 1470. Then the total value, TA total value is 470, 1470, sorry, 1470 whole square meter. What is 1470 to 1470? Tell me. 1470 to 1470, Monica. 1470 to 1470. You are doing.
Yes, sir. I got the answer. 108045.
This is the, we are substituting the answer, we can complicate. Now, you should understand.
Yes, sir.
So that's one problem I will tell you. That is how I square, I will do it and tell you by doing it. Okay?
Sir, I'll be back in 5 minutes. Somebody came. 2 minutes. 5 minutes.
In this block, we are going to discuss introduction to experimental design, basic definitions of experimental design, principles of design, experiment size, shape, and the plots. Completely randomized design, least squares estimates of parameters, F test, and expectation of sum of this test. So principles of experimentation, principles of experimentation, complete design CRD, F test for CRD we can discuss in these units. In these principles of experimentation, there is a scientific method, planning an experiment, steps in experimentation, the role of experimental design, classification of experimental design, basic decisions of experimental design, specific issues of experimental design, size and shape of the blast, principles of experiment design we can learn here. So first we can define the experimentation, different steps in experimentation, understand the terms experimentation, understand the principles of experimentation. So what is introduction? The modern concepts of experimental design is primarily given by Ronald A. Fisher in the 1930. Rotomisted Experimental Station and Agricultural Research Station of London. In Fisher, first book on design experiments, he showed low value conclusions could be drawn efficiency from experiments with a natural function such as temperature, soil conditions, and rainfall. That is the presence of nature's variables, the known variations variable usually cause systematic. Just a minute. So the known resistance variables, usually the systematic bias in the group of results, batch to batch variables. These variables usually known as random variability. The results are called inherent variability noise. The experimental design was first used in agricultural context. This is the agricultural context it is used. The method has been applied successfully in the military and industry since 1940s. SSJ working in the US Naval Experimentation Laboratory, experimental design to solve the problems such as fitting the cause of bad winds in naval shipyards during World War II. George Box is employed in Imperial Chemical Industries before coming to the United States. He is a leading developer of experimental design producing optimizing the chemical process. And Edward Starr, statistical method include the experimental designs, Japanese scientists and engineers in the early 1950s. Japan named Hopewell. Jenichi Taguchi, the most well-known of this group, Japanese scientist, is famous for his quality improvement methods. One of the components where Taguchi first applied his methods was quality improvement initiative known as Total Quality and Six Sigma programs of design of experiments is considered an advanced method in Six Sigma programs, which were pioneered at Motorola and G. According to Bernard Orsted, the design of an experiment, the complete sequence of steps taken ahead of time to ensure that appropriate data will be obtained in a way which permits an objective analysis to vary inference with respect to the stated problem. This is the method, the scientific method. The power of inductive reasoning is that it permits that scientists to formulate general theories about the world based on a particular observation of the behavior of the world. So the problem with inductive reasoning is that these theories are often wrong. The scientific method is a formal statement of procedure designed to facilitate the scientist making the most effective use of his current observations. The scientific method is usually defined to consist of the following coming steps here. The formulation of the hypothesis. How become formulation the hypothesis? Based on the preliminary observation, this is the tentative explanation. This is the first one. Second one, planning the experiment. The experiment must be constructed to objectively test the hypothesis. Careful observation and correction of the data. Fourth one, interpretation of the results. The results of the experiment may lead to confirmation, alteration, or rejection of the hypothesis. We can take care. Planning of experiment. There are some basic points regarding the planning of experiment which should be under consideration. Simplicity. The design should be simple, possible, consistent with the objectives of the experiment. There must be a clearly defined objective. For an experiment is useful, essential to specify the objective perfectly. In other words, the objective of the experiment should be clearly defined here. The experiment should be free from bias. An experiment must be planned so that it is given biased estimate of the values we wish to measure. It is a matter of the design being such that no bias on the part of the experimenter can possibly enter into the results. This is achieved mainly by randomization. There must be a measure of error. You can take the measure of error here. The experiment should have sufficient accuracy. The accuracy of an experiment can be broadly by the elimination of technical errors and by increasing replications. The number of replications should be decided to produce a given degree of accuracy, range of validity, and conclusions. So the range of validity. Conclusion should have as a wide range of validity possible and experimental, replicated in time, and space should be increased. There is a range of validity and a conclusion that could be drawn from it. A factorial set of treatments is another way increasing the range of validity I have on experiment. Calculation of degree uncertainty. The experiment should be designed so that possible to calculate the possibility of the obtaining the observed result by chance. These are 7 important points for that one. Steps in experiment. What is the experimentation here? Define the problem, determine the objective selected treatments, select the experimental material, select the experimental design, select the experimental unit, number of replications, ensure proper randomization layout, ensure proper means of data collection, outline the statistical analysis before doing the experimental, conduct the experiment, analyze the data and interpret the results with a complete and readable report. The role of experimental design. Experimental design concerns the validity and efficiency of the experiment. Experimental design, the following diagram is represented by a movable window through with certain aspects of the true state of nature, more or less destroyed by noise, may be observed. The position and size of the window depend upon the questions being asked by the quality of the experiment. Only used design may not be generate any useful information for meaningful analysis. A wisely designed experiment can provide factual evidence which can easily be analyzed by and understood by the researcher. The diagram emphasizes that although the conjectured state of nature may be false or not least inexact, the data themselves are generated by the true state of nature. This is the reason why the process of the continuity updating the hypothesis and comparing the predicted states of nature, actual data can lead convergence on the right answers. The complete scientific research process, therefore, includes two confident on parallel approaches. Theoretical and experimental statistics offers a powerful tool to help researchers to conduct experiments and analyze data. These two approaches must be integrated to again knowledge the phenomena. The design of experiment must be satisfy the requirement of the objectives of study, but it is also subject to the limitations of available resources. In general, to the objective and hypothesis of the study influence of the design of experiment. This is table you have to see. True state of nature. See here. True state of nature here. Experimental design mobile window. This is a noise what I am taking here. This is design available data and raw data. These two come is their induction. The modification of hypothesis. Hypothesis is child. Then design consequence. This is a hypothesis child. This one replace the child. This is the table here what we are taking here. Then objectives of experimental design. Any type of an. Tell me. Law.
Yes, sir.
Any type of an experimental depends on the objective. This is a theoretical part. The any population temperance can be extended depends on the scope of the study. It is done by the objective of the study. Learn here. Hypothesis and experimental design is the main important of it. Curiosity leads the investigational question that they can be posted in the form of the hypothesis. Hypothesis is the simplest possible answer to a question, stated in a way that is a testable and falsifiable. Hypothesis formulation is a prerequisite to the application of statistical design and analysis, and all hypotheses can never be proved correct, but it can be rejected with no risks of being wrong. The falsifiable thus a chemical can never be scientifically proved as perfectly safe. A null hypothesis can never be proven correct. It can be only rejected with no risk of being wrong. The different N treatments have no effect on the WHO. Alternatively, the different N treatments are significant effect. There is no effect here for null hypothesis, and the effect is a significant effect on yield. So therefore, experimental design we can take here as allows the quantification of uncertainty. The experiment is designed so that the possibility to observe the results is on alone. Then classification of experimental design. Statisticians by them but do not design experiments, but they have developed a number of structured schedules for design, which is the recommender for the taking of measurements. These designs have certain rational relationship to the purpose, needs and physical limitations of experiment. Designs also offer certain advantages in economy of experiment and provide straightforward estimates of the experimental effects and variable estimates of the value. There are a number of ways which experiment designs might be classified. There is a number of experimental factors to be investigated. By the structure of the experimental design, that is log factorial nested response surface. By the kind of information So preliminary intended provider is estimation of effects, estimate of variance, and empirical mapping also. Okay, taking here. Definition, basic definition of experimental design. Several fundamental terms are widely used through this section. They are defined as follows. In an experiment, there are some variants under study, the effects of which measured test these variants will be referred to the treatments. For example, the test I put three fertilizers. What is nitrogen, phosphorus, and potash? This is one. The yield of certain crab, nitrogen, phosphorus, and potash are called treatment. If you are taking these three as called as treatments. Yield. The response of the treatment measured by the sum of indicator, such crop production, milk production, body temperature, mileage, and engine. Such on indicator is called yield. The treatments are applied some units such as yield, field plots, sample of cows, sample of patients, sample of yield, etc. And the effect on the yield is observed. Experimental units. The unit of which treatment applied is called experimental unit. It is the smallest division of an experimental material up to which treatment applied and which the variable under study measure. In carrying out an experiment, we should clear as to which continue the experimental unit. It can be understood that in the field of agriculture, it is called a plot. In the field to animal husbandry, so therefore it's cow means cattle. In the field, the medicine a patient should be in the field of automobile industry, like by Indian said only. This is an experimental material. We have already explained the concept of experimental unit and the materials. Experimental material is nothing but set of experimental units. So a piece of land, a group of cows, a number of patients of a group of Indian sets is actually an experimental material is that on which some of treatments are applied and tested. Blocks 1. Experimental material is divided into number of groups or strata which are so formed they are within homogeneous and between heterogeneous. So therefore these groups of strata are called blocks. Experimental error. These are always why variation between the yields of the different labs, even when they get the same treatment. The variation exists due to non-assignable causes which cannot be detected and explained. There is taken be random test. This is explained the random part of variation is termed as experimental error. This includes all the types of extraneous variation due to inherent variability in the experimental units. Error associated with measurement made and lack of representative of the sample of the population under study. Precision. The precision of an experiment is measured by the reciprocal of the variance of the mean. 1 by Vx bar is equal to 1 by sigma x square is equal to n by sigma x square. This is the one, the relative number of ingredients, precisions. Uniformly dry. We know that the increased efficiency of a design here, so the plot should be arranged in a homogeneous plot. It can be done only if we have correct idea about the fertility variation of the field. This is achieved through uniformity itself. It is known that fertility of soil does not increase or decrease uniformly in any direction, but is distributed over the entire field on erratic manner. By uniform trial, we mean a trial which the field experimental material is divided into small units, plots, and the same treatment is applied in each of the units, and their yields are recorded. From these yields, we can draw a fertility control map, which gives a quick picture of the variation yields. From these yields, we can draw a fertility control map, which is the graphic picture for the variation of the soil, fertility, and variable source. From a good idea. So therefore, the fertility control map is obtained by using the equal fertility. The equal fertility you are doing the conditions here. Travel gives us a fertility gradient of the field, determination of the shape of the flats, use optimization of plots, estimation of number of replications required achieving the certain degree and accuracy. So this is the one significance level of the testing one. Accepted, true, correctly, rejected, type 1 error. So false, type 2 error, correct decision, rejected. ఎందుకు రిజెక్ట్ చేస్తాము ఫాల్స్ టైప్ అయితే దట్ ఇస్ కరెక్ట్ డిసిషన్ షుడ్ బి రిజెక్టెడ్ యాక్సెప్ట్ ద ట్రూ కరెక్ట్ డిసిషన్ దట్ రైట్ వన్ ఎర్రర్ సో దిస్ ఇస్ ద నల్ హైపోథెసిస్ వి ఆర్ టేకింగ్ హియర్ then HO is true. Top significance level by the probability that 1 HO is correct. Generally, alpha less than 0.05, 120. HO is false bottom figure. Lowering alpha increases time to error beta is equal, which is the probability. And conclude HO is true when in fact it is not. The sample belongs to the population which means 74.5. The sample belongs to a different population. See here. So this is the acceptance and rejection. So this is the rejection. I am taking the graph here. This is the rejection part. This type of part is accepted. This type of part is accepted. The only way to reduce the errors to increase the number of replications to improve the experimental design, reduce the error. Specific issues of the experimental design. Once the objective testing questions and the hypotheses are defined, the scope, type, and requirements of experimental are also more or less determined. Thus, the experiment should be designed to meet these requirements, especially experimental design is concerned with the following: the size of the study, number of replications, so therefore units are subject to the treatment and size shape of experimental unit, type, number of measurements, the set of response variables to be measured and the sampling plan that specifies when the components of the experimental unit will be measured. This is the theoretical. All of you write what they will ask. Treatments, the type of treatment, the level of treatment, and the number of treatments. Assignments of treatments and experimental units. The manner in which treatments are randomized and assignment experimental units, completely randomized disease, and a randomized block design, or very means randomized block design. Error control, noise, reduction through strategic use blocking techniques, co-variables, and environmental control. Relative precision of designs involved through treatments that determines to which a design provides more information. Among the above considerations, replication and randomization are the most important basic principles of the design experiment. This is the size, shape of the flash. This is also one question. In field experiment, the field experiment, the size and shape of flats as well as block influence the experimental error. The total available experimental area remaining fixed. An increase in size of flats will automatically decrease the number of flats and directly increase the block size in order to reduce the flow of experimental material from one flat to another. It is customary to view the outreach of land between consecutive flats and also between flats. These non-experimental areas to non-broad area. The size and shape of the flat should be such that we make a compromise between statistical and practical requirements. We plot size x and the variance of the flat Vx, and then Vx is minimum statistical consideration, and there should be no disturbance for agricultural operations. The size and shape of flat will ordinarily be determined by the size, shape of flat, and the number of flats in flat. It is desirable from the point of view error control to have small variations among the flats. In the block variation among the blocks in general region of experimental material to black may be such way the plots within blocks are homogeneous possible. Principles of experimentation is also very important. In this part, randomization, replication, local control. So good experience in art and it depends upon heavily upon the prior knowledge and abilities of the experiment. Designing the experiment means deciding how the observations or measurements should be taken on a particular question in value, efficient and economically. If a design is properly designed, then there will exist an appropriate way analyzing the error. For many, design of experiment, no conclusion can be drawn. So the fundamental principles in design of experiments are all the solutions to the problems in experiment are proposed by the two types of Musicians factors and so the improved efficiency of experiment. So for the validity of the design, this one R.A. Fisher has given three principles of design of experiment, that is randomized, replication, local control. Randomization. What is the randomization? The principle of randomization is essential for valid estimate of the experimental error to minimize the bias of the results. In the words of Cochran, Cox randomization is a last insurance, that is a precaution against distribution that may not occur, may not be serious if they do occur. Thus, the randomization is so that each treatment should be get on equal chance. We mean that the treatment should be allocated randomly with the help of random numbers. The following are the advantages of the randomization. It provides a basis for the test of significance because the randomization assures elements of the observation of the assumptions for the analysis of the variance. It is also device for the eliminating the bias. Bias creeps in an experiment when the treatments are not assigned by randomly to elements. This bias may be personal or subjective. These randomization ensure the validity of the results. So this one discussed will the last one, local control. This method is used to attain accuracy or to reduce the experimental error without increasing unduly the number of repetitions. Local control is a technique to handle the experimental material in such that way that effects of variability are reduced. In local control, experimental units are divided into number of homogeneous groups called blocks. These blocks are so formed that they homogeneous within the heterogeneous between. This blocking of experiment may be row-wise, column-wise, both according to the number of factors responsible for heterogeneity. Different team. Different homogeneous group blocks. These blocks are so formed that they are homogeneous within the heterogeneous between. This blocking experiment may be row-wise, column-wise, or both according to the number of factors responsible for heterogeneity. Different type of blocking consists with different types of experimental design. The following are the advantages of local control. By means of local control, by the experimental error is reduced considerably and the efficiency of the design is increased. By means of local control, the test procedure becomes more sensitive and powerful. Besides that, three principles, there are some other general principles in designing an experiment. Familiarity with the treatments and experimental material is an asset. Selection of the experimental site as an asset. Selection of experimentalists should be carefully done. So therefore, within the black of variability should be reduced. The size and shape of the black ordinary determine the size of shape flats and the number of flats in the black. The desirable from the point we can error control small variation among the plots, the block and variation among the block. In general, the division experimental into blocks made such as why the plots within blocks are homogeneous causal. Monica, this is totally theoretical part. You understood, I think. Monica is there? Monica?
Yes, sir. Yes, sir, I'm there.
Theoretical part, 7th and 8th unit.
Okay, sir.
Compulsory these two questions you have to attend. 8th unit we will discuss tomorrow.
Which
Next to 8th unit also, same theoretical part we can discuss tomorrow.
7th and 8th unit you will tell tomorrow, sir.
7th today completed.
Okay.
8th also same theoretical part we can discuss tomorrow. 9th unit again problems. Okay?
Okay.
What is the doubts? You can write it. We can after evening hours we can discuss.
Okay.
Okay?
Okay.
Right.
Can I leave, sir?
Rakesh, close చేస్తుంది Rakesh. ఎందుకంటే టాపిక్ అయిపోయింది.